In this video, we're going to be looking at solving radical equations. If you find this video helpful, share, like, and subscribe. Solving radical equations, what you will learn, that is first to solve radical equations and identify extraneous solutions. Squaring each side of an equation. If two expressions are equal, then their squares are also equal. Okay, algebraically, if let's say A is equal to B, if I'm going to square A, then B is going to be squared. They are going to be equal in nature. That's what it means. Solving radical equations with radicals on one side. Okay, so let's look at letter A. So the very first thing we're going to do here is to subtract 7 on each side. Okay. So what is left in here is just going to be the square root of x plus 4 is equal to 4. Now we're going to raise both sides to square. Okay, so this is going to be x plus 4 is equal to 4 square is 16. Okay, and then we're going to transpose 4 on the other side. That's going to give you 16 minus 4, and that's going to give you x is equal to 12. Now, the thing that we're going to do here is we have to recheck, okay? Let's recheck if our answer is really correct. So say, for example, in here, x is equal to 12, then let's put that back into the original equation. That's going to be 12 plus 4 plus 7, okay, plus 7. Is it equal to 11? That's what it means, okay? So here, let's continue. 12 plus 4 is going to give you 16. Plus 7 is equal to 11. Is it equal to 11? So that's going to be 4 plus 7. So we can actually see in here that this is going to be correct because 7 plus 4 is equal to 11. Therefore, our answer in here as x equal 12 is correct. Okay, let's go for letter B. Letter B. So the very first thing we're going to do here is to subtract 6 on each side. So that's going to give you 15 minus 6 is just going to give you 9 is equal to the root of 3w minus 9. Okay, so we're going to raise to square or square both sides. Okay, so this is going to give you 81 is equal to 3w minus 9. Okay, putting this 9 on the other side, so that's going to be transposing it. It's going to give you 81 plus 9 is equal to 3w. This is going to give you 90 is equal to 3w. Dividing both sides by 3, that's going to give you w is equal to 30. Okay, as we have done earlier, we have to recheck our answer. Okay, so let's recheck. Here, 15, is it equal to 6 plus the value of our w here is going to be 3 times 30 minus 9. Okay, 15. 6 plus 3 times 30 is 90. 90 minus 9. So that's going to give you 81. 6 plus the square root of 81. Okay, here 15 is equal to 6 plus the square root of 81 is 9. Therefore, we can say that they are both correct now. 15 is equal to 15. Okay, let's go for letter C. Here is our letter C. Letter C, we're going to the first thing we're going to do here is to add 4 on each side. So that's going to give you, here in this side, we're just going to be left with the cube root of y is equal to 5. Okay, then we're going to raise to power of 3 on both sides. This is going to cancel this one. Y is equal to 1 to 5. Okay, as simple as that. Okay, so let's recheck. Let's keep rechecking in order for us to make sure that everything is okay. So the cube root of 125 minus 4, is it equal to 1? So the cube root of 125 is 5 minus 4 is equal to 1. So therefore, we can see that 1 is equal to 1. Therefore, our answer is correct. Okay, let's go for letter D. Here's our letter D in here. So the very first thing I'm going to do here is to immediately raise both sides by the third power. Okay, so this is going to cancel this one. So if you're going to continue with the process, this is now going to give you 3c plus 7, and 10 cubed is going to be 1000. Okay, so here we're going to transpose this one on the other side. That's going to give you 3c is equal to uh, this is 7. 1000 minus 7, this is going to give you 993. Okay, dividing both sides by 3, c is going to give you 3, 3, and then 1. Okay, as usual, we're going to recheck our answer. Okay, so rechecking our answer in here. So we're going to have a cube root of 3 times 331 plus 7. Is it equal to 10? Okay, continuing the process. Okay, we know that 3 times 331 is going to give you 993 plus 7 is equal to 10. So we can see now in here that this is now your cube root of 1000. Is it equal to 10? Yes, 10 is equal to 10. Therefore, our answer is correct. Solving an equation with radicals on both sides. So earlier we have seen equations with only one radical on either side. This time we're going to look at radicals on both sides. Okay, let's look at number 1 in here. So the first thing we're going to do here immediately is to quickly raise both to square to cancel these things, okay? So going further, this is going to give you 2x minus 1 is equal to x plus 4. Okay, let's transpose this one on the other side. So that's going to, and this one is also going to be on the other side. So that's going to give you 2x minus x is equal to 4 plus 1. Okay, so remember that when you're going to transpose this on the other side, the signs will change. So 2x minus x is just x is equal to 5. Okay, so this is going to be our answer. Now, let's recheck if our answer is correct. Okay, if x is equal to 5, then is it correct now? Let's look at it. Our original equation is 2x minus 1. Okay, so this is going to give you the square root of 2x, 2 times 5 minus 1. Is it equal to the square root of 5 plus 4? Okay, this is going to give you 10 minus 1. Okay, is it equal to 9? Here, if you're going to look at it, that's going to give you 9, and this is the square root of 9, therefore it's correct. Okay, so that's how you're going to solve. Okay, letter B. Let's look at letter B. Okay, this is also the same situation earlier, where we can immediately raise to the second power to cancel radicals. And what is left in here is just 2x minus 9 is equal to x. Okay, transposing 2x minus x is equal to 9. Okay, this is, well, negative 9, but when it's going to be on the other side, by transposition, it's going to change its sign. Now, 2x minus x is just x. X is equal to 9. Simple as that. Okay, now the thing that you're going to do next is to recheck whether your answer is correct or not. Okay, so we're going to put back into its original equation. So here you are going to have the square root of 2 times 9 minus 9. Is it equal to the square root of 9? Okay, 18, 9 times 2 is 18 minus 9. Is it equal to 9? 18 minus 9 is just going to give you 9. Therefore, we found out that our answer is correct. Okay, next, let's go to letter C. Okay, let's raise again to both sides with the power of 2 to cancel the radicals. So this is going to give you 3g plus 1 is equal to 7g minus 19. Okay, so this is greater, so I'm going to transpose this one on the other side instead. And this is going to be greater also, so I'm going to transpose it also on the other side. So this is going to give you 1 plus 19, yeah, and this is going to be 7g minus 3g. So this is going to give you 20 is equal to 4g, then divided by 4 on each side. Our g here now is going to give you 5. Okay, letter D. Okay, so the very first thing we're going to do here is to transpose this side on the other side. So we're going to accomplish that by adding root c plus root 4c, I mean. Okay, this will be cancelled out. So what is left here is now your 2c plus 1 is equal to root 4c. And then we can now raise both sides on the power of 2 to cancel out the radicals. Okay, so what is left here is 2c plus 1 is equal to 4c. Okay, so since my 2c in here is lesser, I'm going to put it on this side. Okay, so this is going to be left with here with 1, and 4c minus 2c is going to give you only 2c. Dividing both by 2, this is going to give me c is equal to 1 half. Okay, let's go for letter E. Okay, this is also very interesting. Okay, so the very first thing we're going to do here is put this side again, this one on this side. So we can accomplish that by adding root 8r minus 2 on both sides. Okay, 8r minus 2. So this will be cancelled out. What is left on this side is just 5r is equal to the square root of 8r minus 2. Okay, squaring both sides is going to cancel out the radicals. So here that's going to be 5r is equal to 8r minus 2. Okay, let's see. I'm going to say 2. Transposing this one into the other side will become positive. 8r transpose this one on the other side is going to be negative. So 8 minus 5r. 8 minus 5 is going to give you 3r. Dividing both by 3, simply it's going to give you r is equal to 2 all over 3. Okay, letter F. Last but not the least. So the same again, the same situation. We're going to add root of 6h plus 7 on both sides. Okay, so we're going to have here 6h plus 7. This will be cancelled out. What is left here is only 8h minus 7 is equal to 6h plus 7. Okay, raising both to square, that's going to give you 8h minus 7 is equal to 6h plus 7. Transposing it, that's going to give you 8h minus 6h is equal to 7 plus 7. 8 minus 6 is going to give you 2h is equal to 14. Therefore, h is equal to 7. Let's recheck it, whether we have the same. Okay, let's see. Rechecking. Now, let's recheck it here, putting it to its original equation. So that's going to give you 8 times 7 minus 7, square root, of course. Is it equal to 6 times 7 plus 7? Okay, 8 times 7 is going to give you 56. 56 minus 7 is going to give you 49. Here, is it equal 6 times 7 is 42. 42 plus 7 is going to give you 49. Okay, so 7 is equal to 7. Therefore, our answer is correct. Identifying extraneous solution. Extraneous solution is a solution derived from an equation that is not valid. Okay, solution to the original equation. Okay, so let's give you an example for you to understand. Say, for example, we're given here the root of 6x minus 5 is equal to x. Now, we're going to check which of these two values of x equal to 5 and x equal to 2, is the extraneous one. Okay, for x of 5, let's say 6 times 5 minus 5 is equal to 5. Is it equal to 5? 6 times 5 is 30 minus 5. Is it equal to 5? Okay, 30 minus 5 is 25. Is it equal to 5? Now, here we go. This is 5 equals to 5. Therefore, it's correct. Now, let's look at the second part. What if x is equal to 2? Okay, so this is going to give you 6 times 2 minus 5. Is it equal to 2? Because the value of x here is 2. So 6 times 2 is 12 minus 5 square root. Is it equal to 2? Okay, 12 minus 5 is going to give you 7. So that's going to give you square root of 7. Is it equal to 2? Well, we can conclude that root 7, even if it is in simplified form, is not going to be equal to. Therefore, in this case, the 2 is now what you call your extraneous solution because it is not valid. If once you're going to put it into its original equation, the solution is not actually valid. Solve the following equations. Check for extraneous solution. Okay, so the very first thing we're going to do here is to add x on both sides. So this is going to be just leaving you with 17 minus x is equal to 3 plus x. We're going to square both sides. Okay, what is left is 17 minus x is equal to 9 plus 6x plus x squared. Okay, so I multiplied these two together. Now we're going to put this side on the other side. So what is left on this side is just 0. So it's going to give you x squared plus 6x. This one is going to give you plus x plus 9. And this one is going to give you negative 17. Okay, 0 is equal to x squared. Simplifying this is going to give you 7x. And simplifying this is going to give you 8. Okay, so it's quadratic in nature. That means we're going to factor both of them. We're going to get two factors here. So x and x, the factors of negative 8, that's going to give you negative 7 should be 8 and 1. One should be positive, one should be negative. Okay, so here, in this case, x minus 1 and the other one is 0 is equal to x plus 8. Therefore, the value of my x here is going to be 1. And the other one here is going to be x is equal to negative 8. Okay, so let's check which of these two is called extraneous. Okay, we're going to put it back in our original equation, this one. Okay, let's first try recheck. This is called recheck when x is equal to 1. Let's see. So that's going to give you 17 minus 1. That's going to be under the square root. And then minus 1 again. Is it equal to 3? 17 minus 1 is 16. That's under the square root. And then minus 1 is equal to 3. 4 minus 1 is equal to 3. Okay, we can see that 1 is a solution. Here, 1 is a solution. What about 8? Okay, let's look at the 8 this time. So for 8, when for x is equal to negative 8, we're going to put that into its original equation. Negative 8. Okay, this is going to be under square root. Minus 1 is it equal to 3. Okay, so 17, this is going to give you 17 plus 8, yeah? 17 plus 8 and still under radical root, and then minus 1. Is it equal to 3? 17 plus 8 is going to give you 25. Okay, minus 1 again, is it equal to 3? Now, we can see here that's 5 minus 1 is 3. Now, we can see that this is not equal to 3 because 4 is not equal 3. So, we can say now that this x equal to negative 8 is what you call your extraneous solution. Okay, it just came out because we actually square both sides. Okay, here's the next example. Root of 4x plus 13 is equal to x plus 2. So what we're going to do here immediately is to simply raise both to 2 squared to cancel out what needs to be canceled. Here, what is left is 4x plus 13 is equal to, this is the same as you're going to multiply it twice. So that's going to be x squared plus 2 times one of this and this. That's going to be 2, and then x, and then square this part. This is going to be 2 squared. Okay, so that's still going to be 4x plus 13. This is going to give you x squared plus 4x, and then 2 squared is 4. Okay, we're gonna put this terms on the other side. So here it's just going to be 0. That's gonna give you x squared plus 4x, and this one is going to give you minus 4x plus 4, and this is going to be negative 13. The 0 is equal to x squared. Now we can notice here we have to cancel that part. 4 minus 13 is going to give you negative 9. There you go. Okay, so this is quadratic again. So we're going to put them into their factors. So x and x. This is going to be 3 and 3. 1 should be plus, what should be minus. So here, x will be negative 3 on this side, and the other side is going to be x is equal to 3. Now, let's check which of these numbers or values of x will be extraneous. Okay, now let's go for x is equal to negative 3. Okay, let's go for this. Okay, so that's going to give you, our original equation is this one. So the square root of 4 times negative 3 plus 13, is it equal to negative 3 plus 2? Okay, this is going to give you negative 12 plus 13. Is it equal to, this is negative 3 plus 2 is going to give you negative 1. Now in here we can say that this is going to give you square root of 1. Okay, I don't think they are equal because 1 is not equal negative 1. So x equal 3 is an extraneous. Now let's look at x is equal to 3. So when x is equal to 3, okay, what's gonna be? 4 times 3 plus 13. That's under the radical sign. Is it equal to 3 plus 2? Okay, continuing, that's gonna be 12. 12 plus 13 under the root sign. And then this is going to be 5. 12 and 13 is going to give you 25, still under the radical sign. Okay, I can see that this is 25. The root of 25 is 5, is going to give you 5. So x here is now the real solution, and the other one is not a real solution, and we call it an extraneous solution. So here the extraneous solution is x is equal to negative 3. Okay, here's another one example. So the very first thing I'm going to do is to raise both sides with the power of 2. So here, what's going to happen here is this is going to be 5r plus r is equal to r squared. Okay, I'm going to transfer everything on the other side. So this is going to be 0. That's going to give you r squared plus 6r. Okay, 5r plus r is 6r. Then we're going to factor this out. R plus 6 only. Therefore, the possible solutions here will be 0, and the other one is r plus 6 is equal to 0. R is equal to negative 6. Okay, let's recheck which one is the extraneous and which one is the real one. Real answer to this. So this is going to be 5 times 0 plus 0. Is it equal to negative 0? This is 0. Everything in here is going to be 0. So that's going to be the square root of 0. Is negative 0. 0 is equal to 0. Okay, 0 is one of the answers. Now, what about the second one? Let's go for the second one when r is equal to negative 6. Okay, let's do that again. So 5 times negative 6 plus negative 6. Okay, that's going to give you is it equal to negative times negative 6? Okay, so negative, this is going to give you negative 30, and this is going to negative, so that's going to give you negative 6. Still under the radical sign. This is going to be negative, negative times negative is going to give you positive 6. Are they equal? I don't think so. This is already negative 36, okay, and 6. So we can see that the square root of negative 36 is actually 6i in its very real nature, and 6i is not equal to 6. Therefore, 6 in here is your extraneous. Here's another one. So I'm going to raise both sides to the power of 2. That's going to give you, here on this side is x plus 14 only. The other one, so if I'm going to multiply this one together, that's going to give you x squared plus 4x plus 4. Okay, putting this part on the other side, this will give you 0. X squared plus 4x minus x. This is going to be negative x plus 4, and then this is going to give you negative 14. Here, 0 is equal to x squared. 4 minus 1 is going to give you 3x. 4 minus 4, negative 4 minus 14 is going to give you negative 10. Okay, so it's a quadratic again in nature. So x and x, 5 and 2. Now, I need middle term as positive, so I'll make this positive, and this is going to be negative. Okay, so here 0 is equal to x minus 2, and the other one is 0 is equal to x plus 5. Therefore, the value of my x here is equal to 2. In here, it's going to give you negative 5. Okay, let's check which one is the extraneous and which one is the real root. Okay, when x is equal to 2, okay, let's check. That's going to give you the square root of 2 plus 14. Is it equal to 2 plus 2? Okay, 16. This is the square root of 16 is equal to 4. 4 is equal to 4. Okay, so x equal to 2 is an answer. What about when x is equal to 5? Okay, when x is equal to 5, sorry, negative 5. Okay, so that's going to give you square root of negative 5 plus 14. Is it equal to negative 5 plus 2? Okay, so on this side, this is going to give you negative 3. This is going to give you 9. Okay, so I guess it's not the same because 9 is not equal, sorry, 3 is not equal negative 3. So this is extraneous. This is the extraneous. Another one, we're gonna raise both sides to square. So this is gonna give you x squared is equal to x plus 6. Okay, let's move everything back. X squared minus x minus 6 is equal to 0. Okay, so let's factor these two. They are quadratic in nature. X and x, 3 and 2. I need negative x, so I'll put negative on the bigger sign, plus on the smaller sign. So this is going to give you x plus 2 is equal to 0, and the other one is x minus 3 is equal to 0. Therefore, my x is negative 2. Here, my x is 3. Now, let's test which one is the extraneous and which one is the real root. Okay, let's look at when x is equal to negative 2. Okay, first thing we're gonna do here is to subtract 13 on both sides. So what's left here is just 5 and is equal to negative 10. Then we're going to raise to 2. So this is going to give you 5 and is equal to negative 10 square is the same as 100. Okay, we divide both by 5. So that's gonna give us 20. Now let's check if this is the solution to this problem. Okay, when n is equal to 20, okay, 13 plus 5 times 20. Okay, is it equal to 3? Okay, 13 plus 5 times 20, that's gonna give you 100. Is it equal to 3? Okay, 13 plus 10 is not equal to 3 because 13 plus 10 is 23 and 23 is not equal to 3. Therefore, the answer here is an extraneous. Okay, it is an extraneous. So what about the real answer? There is no real answer to that. There's no real solution because all we found, algebraically speaking, is just extraneous. Okay, here's the last one. 7 plus 3 root 3p minus 9 is equal to 25. So first thing I'm going to do in here is to subtract 7 on both sides. So what's left in here is just 3 root 3p minus 9. 25 minus 7 is going to give you 18. Okay, then we divide both by 3 again to eliminate or to isolate 3p minus 9. 18 divided by 3 is 6, and we're going to raise both to 2 to cancel out the square root in here. So this is going to give you 3p minus 9, and 6 squared is 36. Okay, let's continue the process. So 3p is equal to 36 plus 9. Okay, 3p is equal to 45 divided by 3. Then this is going to give us 15 only. Okay, now let's check if 15 is the correct answer to this equation. Let's substitute everything. So 7 plus 3 times 3 times 15 minus 9, is it equal to 25? Okay, 7 plus 3 times 15 is 45. 45 minus 9 is 36. Okay, 36. Is it equal to 25? Okay, here 7 plus 3, the square root of 36 is 6. Now 3 times 6 is 18. 18 plus 7 is equal to 25. So it is correct. Okay, so our solution is correct. Lesson takeaways. Equations containing radicals can be solved by isolating the radical on one side of the equation, then raising both sides on the same power that would undo the radical. For equations with both radicals, raising them to both same power will also undo the radical. Okay, extraneous solutions occurs in squaring both sides of your work but does not make the original equation true. This is all for this lesson on radical equations. If you find this video helpful, share, like, and subscribe. Thank you very much.